Hey guys, I am going to show you how to do a tree diagram. This is topic E, conditional probability in your packet. We're going to be doing Dan Steiner problem. Um, this is a great way to set up conditional probability where if you see words like if this happens or of these people, that lets you know that we're probably going to be doing a tree diagram. So what you're going to notice is there's two events that we're concerned about in this situation. And the first is who's washing dishes. The second is whether or not the dish breaks. So we're going to start our tree diagram with just individual probabilities that should be given. And so you'll notice that L washes 40% of the dishes. So I'm going to go in there. I have to move that. I can't access my. So you'll see that L washes 40% of the dishes. So that's 0.40. Betty washes 30%. So we'll put 0.30 there. And then Chuck is also washing 30% of the dishes. So we started that out, and you'll notice those are just the probability of one event happening, Al, Betty, or Chuck. Now, as we branch off, you'll notice that it says Al breaks 1% of the dishes that he handles. So as I continue on, now we're going to be concerned with whether or not the dish breaks or doesn't break. So if Al is washing, we know that he will break 1% of the dishes, which means that he will not break 99% because we'll take 1 minus 0.01, which is going to give us 0.99. So all those probabilities should add up to be 1. Betty has the same options. If Betty's washing a dish, she can either break or no break. And it looks as though Betty breaks 1% of her dishes, and then again does not break 99% of her dishes. And then lastly, we have Chuck. And Chuck has a little bit of a higher percentage of breaking, and that would be 0.03. And then the no breaking would be 0.97, because if you take 1 minus 0.03, you'll get 0.97. Now, when you set up a tree diagram is completely pointless if you don't multiply your branches. So that's what I'm going to do right now, is I'm going to take L times break, and I'm going to get an answer. Betty L times no break, get an answer. And I'm going to go through and I'm going to multiply every one of these branches. Again, don't even do a tree diagram if you're not going to multiply the branches. So as I multiply, and just check me on this, hopefully my numbers will be right. I'm getting 0.004, 0.396. Betty with break is 0.003. This is 0.297. This is 0.009, and this right here is 0.291. Now, if we did this right, all of these probabilities should add up to be 1. So it looks like we're doing good there. Now, each of these little pieces has their own unique probability. So it's like it's either the individual probability, it's an or it's an and. And so what you guys are looking at here, and I'm going to highlight this is the sample space. Everything that we're doing, why we do Venn diagrams or tables, is so we can actually find the sample space. So when you have the sample space there, it's going to give you every possible outcome. Now, I always stop here and ask students, okay, well, what do you think this branch right here is? You know, and your options are, is it just the probability of breaking? Is it an or? Is it an and? Or is it a conditional probability? And it turns out that this first branch right here is the probability of L. And that was given to us. So this branch right here is the probability of L. Now what we did is we multiplied this branch right here is the probability of breaking given that Al is washing the dish. So given that that you're on Al's branch. When you take those two probabilities, all of these, the 0.004, that is giving you the probability of Al and break. This is the probability of Al and no break. And so on. The sample space is all of the different ands that are possible. This is Betty. Erase that guy. And a break. This is the probability of Betty and no break. Probability of Chuck and a break. Probability of Chuck and no break. Okay, so we've done all this work. Again, please multiply your branches. You are trying to find the sample space. That's the goal, and that's what we found right now. So now we get to answer the question. And it says that we go to Dan's Diner and we hear a dish break. We're looking for what is the probability that Chuck is on the job. Now these conditional probabilities, I need to see what you're doing. The notation is going to be really important because if you don't get the notation right, you can't answer the question right. So what we're looking for is what's the probability that Chuck is washing dishes given we know that a dish has broken. Who's back there is what we're looking for. So this is actually a conditional probability. Now, when you set up this conditional probability, the denominator is always going to be made up of the numbers where things were broken. So I go to my sample space, and right here a dish was broken. Right here, Betty broke a dish, and Chuck was washing and broke a dish. So now the sample space has been narrowed down to just these three situations. That is what's going to go on the bottom. Okay, so we put those on the bottom. Now, out of these three situations, where, and only these three situations, so really out of these numbers that you have put in your denominator, which one of these was Chuck washing the dishes? And that happened down here at the 0.009. And so our final answer here is 0.56. So when you guys look at your formula sheet, you'll notice there is a formula for conditional probability. And it says, I don't want to be in. Yeah, I'll be there. It says the probability of A given B is equal to. And so in the denominator of this conditional probability, you're going to put B because we know that B has happened. The numerator is going to be that overlap of A and B. On your strawberry sheet, it'll look like that. This right here is the and. And so you'll notice that 0.009 that we have on top, notice that is the and the 0.009. The nice thing about the tree diagram is it kind of sets us up without having to use the formulas. So hopefully this helps for the Dan's Diner problem. And I will see if I can make another one for the other one in your notes. So stay tuned.